Welcome to What's Up Over Edmonton for June of 2024. My name's Jeff Robertson, and I'm a member of the Royal Astronomical Society of Canada, Edmonton Centre. And this is a picture I took during that great display of aurora on May the 10th. This is from my light-polluted backyard. I live in an older neighborhood, so sorry about all the power lines. It was quite the display. Haven't seen a display that bright in the city for a number of years. I call this What's Up Over Edmonton because the skies over Edmonton are fundamentally different than what is presented in a lot of popular astronomy publications like Astronomy Magazine, Sky and Telescope, and what's talked about on the CBC. And the example I've always given is this is the sky over Toronto on July the 5th at 11 o'clock. And I always point out this constellation here, Scorpio, the scorpion, fully above the horizon from its head down to its tail. While in Edmonton, all we ever see on that same day and same time is just the top of the scorpion. We never get to see the whole thing. And it's not only what we can see, but how we see things. And this is a picture I took in February 2023 of an alignment of the moon in the top upper left, Jupiter in the center, and Venus at the lower right. And you can see there it on a bit of an angle, 45 degrees or so. That same night in Bucerias, Mexico, my wife's cousin took a picture of the same scene. And you can see that the three objects are almost in a straight line down the horizon. It's just the ecliptic is a lot different the further south you go. Most of the information I use comes out of the Observer's Handbook, which is put out by the RASC every year. It is 352 pages of just about anything you want to know about astronomy. So what do we got for June? The days are starting to get shorter, and soon it will be winter, which is what my mom would always say on the solstice. She was very much a glass half empty kind of person. So we've got planets in the morning sky. We've got Venus reaching superior conjunction on June the 4th. Well, yesterday, actually. The summer solstice is on June the 20th. Mercury is low in the dusk sky at month's end. And watch for NLCs, noctilucent clouds, and aurora. So I will present the what I call the planetarium portion, which I put together using Starry Night software. And as always, I have pre-recorded it. Let's look at what we can see in the skies over Edmonton for the month of June 2024. And as always, we'll start with sunrise and sunset times. On June the 1st, the sun rose at 5:10 a.m. It sets at 9:53 p.m. for 16 hours and 55 minutes of daylight. There is no night, as we are in perpetual twilight throughout the month of June and well into July. On the 30th, the sun rises at 5:09 a.m. and sets at 10:06 p.m. for 16 hours and 57 minutes of daylight. Looking for planets, let's start in the evening sky. There aren't any. All the planets are in the morning sky, so let's go to the morning sky. So here are the planets in the morning sky on June the 6th. And I've set the time to show them all at 4:50 in the morning, which is less than 20 minutes before the sun comes up. And as you know, in Edmonton, our twilight lasts a long time. So you've probably seen media reports about seeing a parade of planets in the morning sky at the beginning of June. Yes, they are all there, but can you see them all? No, not really. The only two you can really see are going to be Saturn and Mars, and it'll have to be a little bit earlier in the morning because they're going to be washed out in the twilight sky at this hour of the day. But just for fun, let's look at the rise times for these planets on the morning of the 6th. And keep in mind the sun rises at 5:07 a.m. So Mercury, it rises at 4:42. It'll be lost in twilight's glare. Jupiter, which just came out of Superior conjunction last month, rises at 4:33. It's going to be lost in twilight as well. Uranus rises at 4:08. You might be able to see it with a telescope. You're certainly not going to be able to see it with your naked eye. Mars, it rises at 3:21. Yes, you will be able to see it earlier on in the morning. Neptune, a telescopic object, rises at 2:37, and you would be able to see it earlier in the morning with a telescope or binoculars. And Saturn, which rises at 2:25, and you will be able to see it naked eye earlier on in the morning. So let's go to earlier on in the morning when we can actually see something, like at 4 a.m. So Mars will become easier and easier to see as we move further on in the year. As I mentioned, on the 6th, it rises at 3:21. By the end of the month, on the 30th, it'll be rising at 2:19. And it will be getting ever so much bigger in a telescope. But right now, seeing surface details on Mars is probably kind of tough, even with a pretty good telescope. Moving on to Neptune, you will need a telescope to see it or a steadily held pair of binoculars and know exactly where to look. By the end of the month, it's rising at 1:03 in the morning. And Saturn rises at 12:52 in the morning by the end of the month. So it is starting to move into the evening sky, and we'll make a note of that for the July issue of What's Up. And its ring will be considerably thinner than we last saw it when it disappeared into the evening twilight last year. The rings will turn edge on to Earth in March of 2025, and we will not be able to see them at all before they start to open up the other way. And this is just a function of Saturn being tilted on its axis, and its appearance changes as seen from Earth throughout its 29-year orbit. You may have noticed I didn't mention Venus. Venus reached superior conjunction with the Sun. That is, it swung behind the Sun from our point of view on June the 4th, and it will reemerge into the evening sky. Venus is going to be in our evening sky for the next 9 months. And this is the track it will follow in this cycle. Venus goes through 5 tracks through the sky that repeat itself every 8 years. Venus will reach its greatest height in the evening sky near the end of the year. But for now, it will slowly climb into the evening sky over the next several months. Now, I did say at the start of the planet section there were no evening planets. Well, in the words of Arnold Schwarzenegger in the movie Commando,
I lied.
There are a couple planets near the end of the month. Now, I've set the time here for 10:30, which is about half an hour after the sun goes down. So starting around the middle of the month, Mercury starts to make an appearance above the horizon. And also Venus shows up as well. Now on the 30th of June, Mercury sets at 11:16. Venus sets at 10:37. So in the evening twilight, you may catch a glance of Mercury and Venus. Looking at the moon in June, and I've set the time for 11:30. On June the 7th, you can catch a almost 2-day-old moon low in the northwest. On the 9th, the moon passes over the Beehive cluster in Cancer, M44. On the 15th, the moon is near the bright star Spica in the constellation Virgo. On the 19th, the moon is very near the bright red giant star Antares, the heart of Scorpio, the scorpion. On the 21st, the moon is full. Now, normally we say the full moon rises as the sun sets, but on this day, the full moon rises almost a full hour after the sun sets, and it will be the lowest full moon of the year. And when it reaches its highest point in the sky that night, it will only be a little over 7 degrees above the horizon. On the 23rd, it will pass very near the dwarf planet Ceres, which is the largest of the main belt asteroids, you can use the moon as your guide to find Ceres. On the 27th, the moon will be near Saturn, and the following night it will be near Neptune. The summer solstice is on June the 20th. It marks the beginning of summer in the northern hemisphere, marks the beginning of winter in the southern hemisphere. The reason for the solstice, in fact, the reason for our seasons, is because of Earth's axial tilt, 23.5 degrees. And on that day, the Earth's northern hemisphere is pointed directly at the sun. The sun rises in the northeast at 5:04 a.m. and sets in the northwest at 10:07 p.m., giving us 17 hours and 2 minutes and 45 seconds of daylight. And this is a picture taken by one of our members, Luca Van Zella, showing sunset throughout the year. And as you can see on the left, the sun is setting in the southwest, and on the right, the summer sun is setting in the northwest. The official time of the solstice is at 2:51 p.m. Mountain Daylight Time. As I mentioned last month, with perpetual twilight, now is the time to see noctilucent clouds. Noctilucent clouds are formed by the sun hitting ice particles very high up in the atmosphere, about 80 kilometers above the surface of the Earth. So far, I haven't seen any NLCs or seen any reports of NLCs. But hopefully, as we go into June and into July, we will see some of these beautiful displays of these electric blue clouds, which we in Edmonton are in a sweet spot to see. So keep an eye out for NLCs in the north. They're easy to distinguish from regular clouds. Regular clouds will just look black against the twilight glow, but NLCs will glow with a bluish white light. June 13th is an opportunity to observe the lunar X. This is a transitory effect that occurs on the moon when the sun is illuminating the tops of some craters around the crater Werner, and it forms an X, which you can see in a small telescope. I've got two start times from two different sources. One says it'll start around 8:15. The other one says it's going to start around 9:49. So let's kind of split the difference and say start looking for it around 9 o'clock, 9:30. It will still be daylight, and it is possible to see the lunar X in the daytime with a telescope. These are some pictures I took showing the X. Have a go. Later on, as it gets darker, you can also see the lunar V, which is above the lunar X. The sun has been very active. It does go through an 11-year cycle between solar minimum and solar maximum, and we are approaching the time of solar maximum. This is where more sunspots appear on the sun than usual, and there are solar eruptions that throw particles out into space. And if these particles interact with Earth's magnetic field and get funneled down into the atmosphere, they cause aurora. We had a fantastic display on May the 10th, visible even in the city. You can get a notification when there is a possibility of an aurora from aurorawatch.ca, and you just subscribe to that, and they will send you an alert, either a yellow or a red alert, when aurora is likely. And these are just a few pictures I took from my own light-polluted backyard. Sorry for all the power lines. I do live in an older area. Let's quickly look at a few things we can see in the night sky. Of course, we are in perpetual twilight, so the sky never gets completely dark. So I've set the time and date for mid-month at midnight. So if we look to the north, we can see the bright star Capella here. In pictures of noctilucent clouds, Capella features quite prominently. Off in the northeast, we see some of the constellations more associated with autumn, and early winter starting to arise. Perseus and Pegasus. Perseus here, the hero, and Pegasus, the upside down flying horse. Within these two constellations are a number of deep sky objects, which will probably be a little tough to see right now, but you can give it a try. Most notably in Perseus, we have the double cluster, NGC 864 and NGC 869, and these are two open clusters of stars very close to one another. If you have a wide field telescope, you can get them both in the same field of view, and they'll both show in the field of view of binoculars. And above the legs of Pegasus is the constellation Andromeda, the chained woman. You see the great galaxy Andromeda M31 with its satellite galaxy M32, and above it the M110. They're better viewed later on in the fall when the sky is much darker. Because of perpetual twilight, I'm not going to dwell a lot on deep sky objects, but I will point out that the constellations Cygnus, Lyra, and Aquila are now fairly high in the sky at midnight, and of course the brightest stars in these three constellations make up the summer triangle. And there it is there. And last year I dealt with all three constellations and the dark sky objects you can see within the three constellations. If we look straight up, we can see a couple asterisms here. The more famous keystone of Hercules, which is this guy right here, which contains M13, the brightest globular cluster you can see from Edmonton. It's a lovely sight, and even with perpetual twilight, a medium to large telescope will be able to make it out. And then M92, which is another smaller but equally magnificent globular cluster. And then we have another keystone-shaped figure, which is actually the head of Draco, the dragon, which is one of the larger constellations in the sky. I'm just going to talk about one more thing, and that is something which may have already happened. I do record this section a few days before I actually present it, so this might have already happened. But there is a possibility of a nova occurring in the constellation Corona Borealis. And it will involve this star here, known as T Corona Borealis, or if you like, HD 143454. It's nicknamed the Blaze Star. It's actually a binary star involving a red giant with a white dwarf orbiting around it, and the white dwarf taking material off the red giant and depositing it upon its surface. And every 80 years or so, the material on the surface of the white dwarf builds up to a critical mass, and then it explodes into a nova. Now, normally this star is a magnitude 9.8. It's well below naked eye visibility. But when the nova goes off, it brightens to magnitude 2, which means you can see it in the city. The star has been seen going nova every 80 years, and we're due to have it go off this year. And the smart money says it's going to go off sometime between June and September. So keep an eye out. Go out and get familiar with the part of the sky where Corona Borealis sits. And hopefully, one of these nights you're going to go out there and see a star that wasn't there the last time you looked at it. And that is the nova. This is literally a once-in-a-lifetime thing. So that's about all I've got right now.
Alistair, do you have anything to add?
If there are any questions?
I had a look for T-Core Bore last night, and nope, still has not blown up. So anytime.
Yeah. Well, it's clear right now, so hopefully it'll be clear tonight, and I'll go out, have a look, and maybe I will see that new star.
Yeah.
Yeah.
And it's super easy. I mean, technically you don't need binoculars, but with the lighter sky, binoculars do help. But once you get familiar with that C-shaped pattern, it's all of less than 5 minutes to just have a look and see if it's there.
Yep. Okay. All right. Anything else from anybody? Okay. We will go on to the moon.
What do you see when you look at the moon? When it's full and round, do you see a balloon? Does it look like a cookie with the bite taken out? What do you see when you look at the moon? It follows
Okay, so the moon is new tomorrow on June the 6th, on D-Day. First quarter is on the 14th. As I mentioned in the planetarium section, the moon is full on the 21st. And the June moon is known as the strawberry moon. Also has a number of other names: the berries ripening moon, the green corn moon, the hot moon, the mead moon, the horse moon. Don't know why a horse moon, rose moon, honey moon. Mead, rose, honey refer, as it's so low, it's got that yellowy color to it, like honey or mead. Or the trees fully leafed moon, which in my backyard block out my view of some of the stars. And third quarter is on June the 28th. So I normally pick out a feature from one of the lists on the RASC Explore the Moon certificate program for either telescopes or binoculars. Today is from the telescope program, but this feature can be seen with binoculars. And the feature is a crater. Endymion is a large walled crater. That's its location there, located close to the moon's northeast limb near Mare Humboldtian, or the Humboldt Sea. And this is one of my world's worst astrophotographer pictures of the moon, and I have circled the crater there. And this is a better picture. Not one of mine, obviously. So the crater's in the center of the picture, and below are the large craters of Hercules on the left and Atlas on the right. This crater is 126 kilometers wide, and it is very old. It was formed around 3.9 billion years ago, and it's best seen 3 days after new moon, or a couple days after full moon, when the sun angle on the crater is quite low. The floor of the crater is quite dark, and it appears fairly flat. So this is a picture from the Lunar Reconnaissance Orbiter. So looking straight down, you can see the walls were terraced, but billions of years of erosion from micrometeorites has softened the features. And there is a line of 3 craterlets that I've circled towards the north end of the crater. And each one of those craterlets is approximately 3 kilometers wide. Some amateur observers have reported being able to see those craters. Because of where it is on the moon, the view is foreshortened, and the crater looks oval, but as you can see from looking straight down, it is round. And the crater was named after a character in Greek mythology, a handsome youth who was visited every night by the moon goddess Selene, who loved him. Those Greek gods, they were a randy bunch. Now, for some time, I've been using the RASC Explore the Universe certificate program as a guide for which constellations to highlight each month, and tonight's no exception. And today is Libra the Scales. And this is the star field shown in perpetual twilight. This is the astronomical drawing of the constellation. And this is a drawing of the scales that the ancients saw. It's the only constellation of the zodiac to be named after an inanimate object rather than a character or an animal. And the constellation was associated with harmony, balance, and justice. Now, Libra lies between the constellations Virgo and Scorpio. And in earlier times, some of the stars of Libra were part of the claws of Scorpio. Now, both Virgo and Scorpio are chock-a-block full of deep sky objects. Virgo with dozens of galaxies, and Scorpio with a number of nebulas and clusters. But Libra seems to have missed out on all this. It does contain one globular cluster, and that is NGC 5897, which is located 50,000 light years from Earth and shines at a magnitude 9. And there is a photograph of that cluster. Libra is not a very bright constellation. There's only 2 stars within the constellation that are brighter than 3rd magnitude, and the brightest is Alpha Libra, which is shown in red, and it's also formally called, and I'm sorry if I get this wrong, Zubanel Gen Ubi. I'm not going to say that again. And it is a binary star system. The primary is a blue-white star, magnitude 2.7, and the secondary is a white star, magnitude 5.2. And they're approximately 75 light years from Earth, and this star is part of the RASC's Double Star Certificate program. And this is an image of those 2 stars. So let's go to space history. So this is where we look at a past event that not only occurred in this month, but whose anniversary year is divisible by 5. So in 2024, we look at events in years ending in 4 or 9. So if someone asks, where does space begin? The accepted wisdom is that it begins at the Kármán line, 100 kilometers or 62 miles above sea level. Now, the line originated with Hungarian-American engineer and physicist Theodor von Kármán, who came to the United States in 1930, and with others founded what would later become NASA's Jet Propulsion Laboratory. Now, seeking to understand the limits of aerospace design, von Kármán assessed the distance from Earth at which an aircraft could no longer rely on the force of lift to stay aloft. And his rough calculations arrived at a figure close to 84 kilometers or 52 miles. Now, an associate of his, Andrew G. Haley, proposed that the number should indicate the boundary between the atmosphere and outer space, and he named it after Kármán. And then later, seeking a nice round number, the Kármán line was raised to 100 kilometers above sea level. So passing the Kármán line meant you were in space. In the early 1960s, the French organization that keeps records of aeronautical feats formally established 100 kilometers as the beginning of space. So today, our rockets pass the Kármán line regularly, sometimes on a daily basis. Rockets like the Russian R-7 or the European Ariane or the SpaceX Falcon 9 or the Boeing Starliner. I did make this earlier. I had no idea that I would have bet money that they wouldn't get that thing off the ground today, but they did. So good on them. And if you have money that you don't know what to do with, you can buy a seat on a suborbital rocket ride above the Kármán line. It's all old hat now, but the first man-made object to cross the Kármán line and enter space was 80 years ago this month, and it was a German A4, more commonly called V2 rocket, launched from Peenemünde on the Baltic Sea coast. The V2, or Bergendenschwaffe, Vengeance Weapon 2 was the world's first mass-produced liquid-fueled rocket and the first ballistic missile, and it was developed and funded in Nazi Germany in the 1930s and 40s. And its first successful flight was in October 1942. And there it is on its mobile launcher. The V2 stood 14 meters or 45 feet 11 inches tall and had a body width of 1.65 meters or 5 foot 5 inches and was 3.56 meters or 11 feet 8 inches across its base fins. The dimensions of the V2 were worked out so that it could be transported horizontally through German railway tunnels. It had an empty weight of 8,842 pounds. Fully fueled, it weighed 28,478 pounds. It had a single engine that generated 56,000 pounds of thrust and carried a 1,000 kilogram warhead. Its operational flight plan took it to a height of 88 kilometers and a range of 320 kilometers or 200 miles. Originally, the Germans planned to launch the V2 from fortified bases on the west coast, but these were discovered by the Allies and bombed before they could be used. After that, the missile was carried on a mobile launcher and could be fired from any suitable location. The engine, which weighed just over a ton, used a fuel of ethyl alcohol and liquid oxygen as an oxidizer, and it used a mixture of concentrated hydrogen peroxide and potassium permanganate as a catalyst to generate steam to drive the turbopumps, which fed the fuel and oxidizer into the combustion chamber. Unlike today's rockets, which gimbal their engines to steer, the V2's motor was fixed, so instead, it used 4 graphite vanes in the motor's nozzle to deflect the exhaust and steer the rocket. So, on June the 20th, 1944, a V2 was launched, not on a ballistic trajectory, but straight up, and it reached an altitude of 176 kilometers, becoming the first man-made object to reach space and making the first suborbital space flight. So on that day, you can say the space age began. Of course, the money poured into the V2 program by the Nazi Germany was to develop a weapon. And on September 8th, 1944, the first V2 was fired on London. And over the next 6 months, over 3,000 V2s were fired on Allied targets, mostly on London or the port of Antwerp. There was no defense against this weapon once it launched. The only defense they had is if they happened to find it, a launch site before the thing took off, Allied aircraft would attack it. It arrived at supersonic speed and killed 9,000 people. And it was only when the Allied forces pushed the Germans back far enough to put the V2 out of range that the attacks ceased. And that was on March 27th, 1945, when the last V2 was fired. Following British bombing raids, production of the V2 was pushed to an underground facility near Dachau concentration camp, and they used slave labor working in horrific conditions to build the V2 rocket. It's ironic that more than 12,000 people died building the V2, more than died from its use. As a weapon, the V2 was not very effective and did not influence the outcome of the war. It carried a 1,000 kilogram warhead and could only be used once. Also, it wasn't very accurate, many times landing in the middle of nowhere. Contrast that with either the RAF Lancaster or Halifax bomber, which could each carry over 6,500 kilograms of bombs, was much more accurate, particularly near the end of the war, and could be used over and over again. In 1944 dollars, Nazi Germany spent $2 billion on the program, which was the same as what was spent on the Manhattan Project that developed the atomic bomb. Near the end of the war, the scientists and engineers who worked on the V2 were sought after by both the Americans and the Soviets, and a large group of these Germans, along with truckloads of material, including complete rockets, surrendered to the Americans in early May 1945. And among the group was Werner von Braun, who would work for the US Army and later NASA developing the Redstone rocket as well as the Jupiter and Saturn series of rockets. And von Braun is the guy with the cast on his arm. He broke it just before surrendering to the Americans. Von Braun became kind of a celebrity on the writing articles on the future of space travel, and even assisted on a series of space flight programs for Walt Disney. In 1960, Hollywood made a movie based on his life, I Aim at the Stars, but memories were still fresh back then, and a comic at the time added the tagline, "But sometimes I hit London," to the movie's title. Von Braun's Nazi past is still debated today. Even though it was developed by a regime that personifies evil, there's no doubt that every liquid-fueled rocket flying today can trace its roots back to the V2. And despite it being a weapon of war, there was no taking away that it was the first object conceived and built by humans to venture into space 80 years ago this month. So these are a few pictures I took of a V2 in the London Science Museum a few years back. There's a close-up of the inside. You can see the motor below it and some of the plumbing above it, including one of the tanks for the hydrogen peroxide used to drive the turbo pumps. The way they put it, they had the nose sticking into the ceiling. I saw one at the Imperial War Museum as well, but for some reason I never took a picture. But his nose was not sticking in the ceiling. This rocket, this V2 here at the Science Museum, was close enough you could actually touch it. And so I wrapped my knuckles against the fin, and it's just thin sheet metal. And it sounded like the ductwork in my basement. So, Heavens Above is a great source of information on all things astronomical. You can produce custom sky charts. You can keep an eye on satellites, comets, that nova when it appears. Great source. The next What's Up is going to be on Wednesday, July the 3rd at 7:30 Mountain Daylight Time. The next meeting of the RASC will be Monday, June the 10th. It will be the last meeting before the summer break. But I don't know if anybody's going to be there because we might all be watching the hockey game. I don't know. So with that, I will say thank you. And if there are any questions or comments, I will try and address them.
Is there any advantage to coming to the meeting as opposed to Zooming?
Well, you get to meet all of us
Well,
and have
I
a
know
chat.
that
We have snacks.
let's see, is that worth 3 hours of driving?
Oh, okay. Yeah.
Okay.
Not
Right.
really.
Yeah. You can watch, I don't know if you ever watch our meetings on YouTube, but you can.
Yeah, I've watched all of this from this year.
Okay, well, you can see how a meeting actually happens, with all the mistakes and pauses and computer problems that all gets edited out in that YouTube video.
Well, we'll see. Maybe we'll give it a shot.
Yeah, yeah.
It's like being at the hockey game, right?
Well, yeah. There's nothing like being there.
Yeah.
Yeah, I
Jeff,
know.
there's a question in the chat.
Oh,
How do they calculate the age of craters on the moon?
by the erosion of the of the by the erosion of the features around it. A young crater will have very sharp features. It'll have rays and that. But older craters, which is most of the lunar highlands, the white part of the moon you see is the old part, and it is very much eroded and that. So that's how they do it.
Yeah, there's a lot more technical sub stuff, but yeah, it's beyond me. You need to be a geologist.
Yeah. Yeah. Obviously, they haven't landed over in that part of the moon to pick up rocks. But, they did land in 6 spots and picked up rocks and found the rocks did vary in age, always billions of years old, but some were more older than the others. So.
So I got a question in regards to if they start walking around on the moon, what kind of lens do you need to watch them through your telescope?
And there's nothing on Earth that'll work.
Oh, okay.
Even yeah, even it's a common question actually. It's even Hubble cannot see the flag from Apollo 11.
Really? Okay.
Yeah,
We can't even see the lunar module either. So, and that's the biggest thing there.
Yeah, it's really surprising. Like in an average telescope here, you can see about a 1 kilometer feature on a good night. And then, so the Hubble is not a lot closer to the moon. It is a little bit, but not a lot. And yeah, it's essentially, it's 10 times bigger than a scope. And so, yeah, it can only resolve, I'm not sure what the actual number is, but it's like 30 meters. Anything smaller than that, and can't see it.
Yeah, I did a calculation, theoretical based on Hubble's, focal length and all that. And I came up with something just a little bit smaller than Commonwealth Stadium would be the smallest thing the Hubble could see on the moon. But Hubble doesn't look at the moon. It's too bright. Could damage its instruments if it did that.
Yeah, it's one of those funny, uh, this and that, where it's just like you can see galaxies billions of light years away, but seeing, planet X at the edge of the solar system, it's too faint.
Yeah. It's too close, maybe.
No, just too faint. It's all about how much light you can gather.
Ah.
And it's just at the edge of the solar system, there's the only light is from the sun reflecting off, something dirty, dark. And so it's very little light comes back. Whereas these powerhouses at the edge of the universe, they're putting out essentially, a few, no, yeah, it's a couple of billion times the brightness of the sun. So it can detect that.
Yeah. Yeah, there's published pictures from the Lunar Reconnaissance Orbiter of all the Apollo landing sites. And as well, India and China's orbiters have imaged the sites as well. I mean, so if you want to see what the sites look like, go to the Lunar Reconnaissance Orbiter and type in Apollo landing sites, and they're all there. Apollo 16, while you cannot see the flag, you can see the shadow of the flag. Apollo 11, you wouldn't be able to see the flag because it fell down when they took off. So it's just lying there on the surface, and it would have been bleached white by now. So.
The perspective of time is really funny because when you said we entered the space age 80 years ago, it's like, no, we didn't. And then, oh, yeah, yeah, yeah.
Yeah, you don't look that old.
Yeah. 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 Well, time is going by quickly. The older you get, the faster it goes, Remember here, reading and seeing the coverage of the 40th anniversary of D-Day, and that didn't seem that long ago to me. And back then a lot of those guys were still around. Now there's hardly anybody left. So you. All right. Well, if there's nothing else, I'll say thank you. Thank you very much for joining us tonight. This is being recorded. I will edit it and put it on YouTube in a few days. And yeah, let's see if there's something else in the chat. Usually 2 to 3 weeks.
Thank you.
Oh, right. Okay. Okay. All right. Well, thank you. Thank you very much. And I will say good night, and hopefully we'll see you either at the meeting next Monday or maybe here next month. So thanks, and have a happy solstice, everyone.
Good night.
Good night.
night,
Thanks.
Jeff.
Thank you. Thank you.